In this lecture, we are moving on to center of gravity of plane sections from geometrical considerations, center of gravity of geometrical sections, reference axis, axis of symmetry, center of gravity by method of moments, center of gravity of sections with cutout holes. So these are the things which we are going to discuss today. So in general, we are going to discuss about center of gravity only. Okay. So you all know what is center of gravity. So all you know that every particle or a body is attracted by the earth towards its center, right? So everything is attracted towards the earth through its center. Okay. So we are assuming that the entire weight of the body is concentrated at a particular point. Okay, if a body has a weight of W, we are assuming that the weight W will be concentrated at a single point, will be acting at a single point. That particular point is known as center of gravity. Okay, the point through which the whole weight of the body acts irrespective of its position is known as center of gravity. It can be briefly written as CG. And every body has one and only one center of gravity. Only a single point through which the entire weight acts. That is known as center of gravity. Another related term is centroid. The plane figures, for example, we have already told about bodies which have weight. Okay, there are some plane figures which has no weight, just plain. They are just plain, very less weight, and they are just plain. So just like triangle, quadrilateral, circle, etc. In that case, there is no mass. Okay, much mass is not there. So we can say that the center of, they have only area, right? They have no mass, so they have only area. So in that case, the center of the area is known as centroid. Center of that particular area is known as centroid. Okay, so it is similar. Center of gravity and centroid is similar. In the case of this plane figures, the center of gravity will be equal to centroid. Okay, centroid will be equal to center of gravity. So it can be used synonymously. Centroid and center of gravity can be used synonymously in some cases. So that is the relation between these two terms. Now, how to find this center of gravity? There are mainly three methods: by geometrical considerations, by the geometry of the figure, whether it is circle, whether it is a triangle, whether it is a road, whether it is a cone, or like that. According to the geometry, we can find the center of gravity by using some equations. Second thing is by taking moments. You all know what is moment. So by taking moments also we can find the center of gravity. Third method is by graphical method. So it is very tedious and very difficult process. So we will not use this method properly. So we will use mostly these two methods. By geometrical considerations as well as by moments, we will find the center of gravity of a particular body. So we will see each of them. First, the center of gravity by geometrical considerations. According to the geometry of the figure, how can we find the point at which the entire weight of the body acts? Okay, that is by geometrical consideration. First thing is center of, so we have some 11 bodies here. 11 geometrical figures are there. So we are going to find the center of gravity of that particular figures here. Okay. Now the first one is uniform road. A road which is very uniform. Where will the center of gravity of that particular road exist? So here you can see this is the road, and the center of gravity of this road will exist at the middle point of the road. Exact middle point. If this board is of 10 centimeter, then the center of gravity will be acting at 5 centimeter of the road. Okay, so the weight will be acting at the center. So this is about a road. Second thing is a rectangle or a parallelogram. In that case, where the center of gravity will be acting. So in this case, we just have to draw two diagonals. Two diagonals. Okay, diagonal AC and diagonal DB to the rectangle or parallelogram. In the case of parallelogram also we can do that. And the two diagonals will meet at a point. That point will be the center of gravity of that particular figure, whether it is rectangle or parallelogram. Okay, in the case of rectangle, these points will lie at half the distance of length and half the distance of breadth. Okay, its breadth is h, and h by 2 is half the distance of breadth, length is L, and half the distance of L, length is L by 2. So the center of gravity will be lying at exact midpoint. Okay. Third case is of a triangle. How to find the CG of a triangle? In the case of a triangle, what we have to do is we have to draw bisectors. I don't know whether you know bisectors. You have to draw a point, a perpendicular, a median line connecting the vertex and the middle point of the opposite side. So here you can say this is BC and D is the midpoint of BC. We will connect this D with opposite vertex A. Like that, for all the sides we will do the same. E is the midpoint of AC. So in this figure it is not like that. Anyway, E is the midpoint of AC and we will connect E with opposite vertex B. F is the midpoint of AB and we will connect F with C. So all these 3 points will meet at a point. All these 3 lines will meet at a point. That point will be the center of gravity of a triangle. In the case of a trapezium you all know, trapezium is a figure having 2 parallel sides. Okay, its opposite sides are parallel. Only one set of opposite sides are parallel. That is known as trapezium. And in case of trapezium, with parallel sides A and B is at a distance of h by 3 b plus 2a by b plus a measured from the side B. So in case of this trapezium, the CG will be lying at a distance from B, at a distance of h by 3 into b plus 2a by b plus a. So this is already proved. This proof is not necessary for you. So this is the place at which center of gravity of trapezium is lying. Okay. In case of a cube you all know it is a figure having or a geometrical figure having all the sides equal, all equal sides. Okay, so that is known as a cube. Cube has, if the side of a cube is L, then the center of gravity of that particular cube lies at a point where all the L by 2 meets. L by 2 from here, L by 2 from here. That is very much at the center point or middle point of this cube. Center of gravity lies at the middle point. In the case of a sphere also, it lies at the exact center point. That is d by 2 from every point. D is the diameter of the sphere and d by 2 is the radius. So it lies at the very midpoint of that sphere. In the case of a semicircle means half a circle. Okay, in the case of a semicircle, it is at a distance of 4r by 3 pi from its base measured about the vertical axis. So this is the center of the semicircle. We are taking a distance 4r by 3 pi from the center. So this point will be the center of gravity. In the case of a circular sector making semi-vertical alpha is at a distance of, so we are taking a sector. Sector means a part of a circle. Okay, a part of a circle taken from its center is known as sector. So when we are taking a sector having an angle alpha with the center, then the center of gravity of that figure lies at a distance 2 by 3r sine alpha by alpha from the center or vertex. Okay, so this at this point the G will be lying. So this is about a sector. In the case of a hemisphere means half a sphere. Okay, in that case the CG will be lying at a distance 3r by 8 from the center. 3r by 8 from the center of the hemisphere. In the case of a right circular solid cone, it is a cone. This is a cone shape. And in the case of a cone, the center of gravity lies at a distance of h by 4 from the center of the cone. H by 4 from the center of the cone, where h is the total height of the cone. Okay. In this case, r is the radius of that sphere. And finally, for a segment of a sphere, earlier we have discussed about the segment of a circle. Here we are taking a segment of a sphere. Sphere means it is 2-dimensional. Circle means it is 1-dimensional. So in case of a sphere, it is 3-dimensional. So a segment of a sphere, it is at a distance of 3 by 4, 2r minus h the whole square divided by 3r minus h, distance from the base of that particular sector. So CG lies at this point. So these are the things. Here h is this distance, the height of that particular segment, r is the radius of that sphere which makes the segment. Okay. So this is about the center of gravity of finding out by geometrical considerations. Now the second thing, how to find the center of gravity, is center of gravity by moments. Moments, you all know, we are taking moments. Force into perpendicular distance. That is moment. Okay. For taking moments, what we are doing is, consider a body of mass m whose center of gravity is required to be found out. So we are considering a body whose geometrical what is that center of gravity is not known to you. We don't know how to calculate the center of gravity of a particular figure. In that case, what we are doing is, we will divide the figure into a number of small masses. Number of small masses, we will divide the figure. Okay. And each of that having a mass m1, m2, m3, m4, etc. And the coordinates x1, y1, x2, y2, x3, y3. Like that we will take the coordinates. So this, we will divide a figure into a number of parts having mass m1, m2, m3, etc. Coordinates x1, y1, x2, y2, etc. And now what we are doing is, we will take the moment of each of that particle. Each of that particular particle, we will take the moment. M1 x1, M2 x2, M3 x2, M4 x2, like that we will take. And we will find the total moment. That is mx bar. Okay, we will find the total moment. Now, the coordinates of the center of gravity can be taken as x bar and y bar. So, center of gravity is lying somewhere here. Maybe we can assume. Okay, that coordinate will be x bar, y bar. So, we can say that x bar will be equal to sigma mx divided by m, and y bar will be equal to sigma my divided by m. Taking moments about y axis and taking moments about x axis. Okay. So this will be the coordinates of the center of gravity. Okay. So at that point, the center of gravity will be lying. So for an irregular figure, or for a figure whose center of gravity is not known, we can use this method, the method of moments. Now a term is there, axis of reference. So axis of reference means from which axis we are taking the center of gravity. A reference axis may be there from which we are taking the center of gravity. For example, here I have told you that here in this case we are taking the center of gravity. The center of gravity of this segment will be from this axis at a distance of this. We have told that. So we can take it as the reference axis is this. The reference axis is the base of this segment. So that is known as reference axis. The axis from which we are taking the center of gravity. Reference we are taking as the reference. So here in this figure we are taking x-axis as the reference. X-axis as the reference. In some cases we will take y-axis as the reference. So that is known as reference axis. For taking moments, we will take x-axis as the reference, and then we will take y-axis as the reference. So that axis are known as axis of reference. Now by moments, we can calculate the center of gravity of different figures. For plane figures, what we are doing is, in case of plane figures means circle, triangle, T section, L section, like that. Okay, plane figures. So plane figures, the center of gravity and centroid will be equal. Center of gravity and centroid of the figure will be equal because they have only area. Okay, they have no mass. They have only area. I have already told you that. So in that case, the centroid and center of gravity will be equal. So in case of plane figures, we can calculate the centroid or center of gravity by using the moments equation, that is x bar is equal to a1 x1 plus a2 x2. We are taking here area because they are plane figures. They don't have a mass. So we are taking area here. a1 x1 plus a2 x2 plus a2 x, a3 x3 etc. divided by a1 plus a2 plus a3. So while doing problems, it will be very much clear to you. So these two equations are used. These are the coordinates of the center of gravity or centroid. Second case is we are finding center of gravity of symmetrical sections. Symmetrical section means here in this figure you can see this is a T section and it is symmetrical. When we draw a line through the center of this section, at left side and the right side it will be equal, it will be symmetrical. So we can say that this is a symmetrical section. In such a kind of section, we no need to find the center of gravity in both the directions, x and y direction. It is not necessary. So at only one axis we can find the center of gravity that will be equal to the other. Okay, x will be equal to y in that case. So that we can see. Actually this figure is not like this. So anyway, okay, so that is the case. In case of unsymmetrical section, so this is an L section. Okay, fine. So in this case, for symmetrical section, we have to find only the center of gravity with reference to one reference point. It is not like x equal to y. It is, we can take the reference axis as xx only, either xx or yy. So for finding center of gravity, we can take only one equation. Okay, by using only one equation, we can find the center of gravity. That is the thing. Okay. In the second case, unsymmetrical section. Unsymmetrical means, so here this is an L section. When we are drawing a line through the center, it will not be symmetrical at both the sides. So in this case, we have to find the center of gravity through xx and yy axis. While doing problems, it will be clear to you. And for solid bodies means hemispheres, spheres, cylinders, etc. They are solid bodies having three-dimensional structure. In that case, more than mass, there is a volume for that. Okay, there is a volume for that. So in that case, other than mass and area, we will consider volume of the figure. Okay, volume into x1, volume into x2, like that we will consider. So volume of some such solid bodies are given here. Volume of a cylinder is equal to pi r square h, you all know that. Volume of a hemisphere is 2 pi by 3 into r cube. Volume of a right circular solid cone volume is pi by 3 r square h. So these are some of the equations which will be helpful while calculating the center of gravity of solid bodies. So we will see it while doing problems. And finally, the center of gravity of cutout holes. Cutout holes means there is a plane figure. From that figure, we have cut out some holes. So here you can see that we have cut out a cube, not cube, a square of diagonal r distance from this circle. So this is known as cutout hole. So well, considering this cutout hole, the center of gravity of this cutout figure. So this is a figure having a cutout hole. What we are doing is, we will first find the center of gravity of this entire figure, that is the circle. So circle was the large figure. So we will find the center of gravity of this figure, and then we will find the center of gravity of this figure, and we will subtract these two. Then we will get the center of gravity of this cutout hole. Okay. First find the center of gravity of the circle, then find the center of gravity of the square, and then we'll subtract these two for getting the center of gravity of that cutout hole. So the equation will be like this: a1x1 minus a2x2 divided by a1 minus a2, where a1 and x1 are the area and distance of this area and not that moment of this circle, and a2 and x2 are the moment of this square about x-axis, and this is about y-axis. So this is the thing. Okay, so this is about today's lecture. Thank you.